Hello TaleForges. In today's material we'll focus on the implementation of triggers in ECS. Our goal is to reach a certain point, detect the player and activate the UI where we can move on to the next level. So let's dive in and see how to implement this. Firstly, we want to separate the logic of the menu from that of the game. So we assume that we will create a second scene, menu, which will be the start scene and from which we'll launch the game scene. Of course, this scene can be freely modified, for example by adding options, credits, etc. But we will focus on just starting and quitting the game. In today's video, we'll focus on the part where the player is detected by the trigger at the end of the level. In the next video, we'll implement switching between menu and game scenes and ECS subscenes. So let's create a new sprite object, which we name EndFlag. As always, texture is set to sprite2D and UI. Set sprite to EndFlag. Then add new component, PhysicsShape. Set collision response to raise trigger events. In the collision filter settings, let's add a new physics category name, EndFlag. Then select EndFlag for belongs to and player for collides with. Of course, let's make a prefab from the EndFlag object. Also, let's clean up a bit here, create two folders, bullets and player, to group prefabs. Set uniform scale to 4. Next, duplicate ground and position it in the scene. Also, position EndFlag to match the position of the ground. Now it's time to create a next level window in the UI canvas. Let's duplicate GameOverWindow and rename it to NextLevelWindow. Set left and right position to 200, top 700, bottom 900. Also, let's change the color of the background to more orange. Rename objects to NextLevelButton and NextLevelText. Next, change anchor of NextLevelButton to center. Adjust position and change width to 450. OK, go to localization tables and add new record, next level, for English and Polish localizations. Now let's back to next level button, select text and change string reference to next level. This is it for the Unity editor configurations. Let's get to coding. I'm committed to stateless collisions, and while we could use the stateful triggers discussed in the official Unity examples, link in the description to the video, for this task, we're going to approach the problem in fundamentally different way. We can refactor the PlayerGroundSystem class to PlayerDetectionSystem, which will be responsible for detecting when the player collides or triggers entities in the game world, and for setting flags when an entity is detected. Of course, changes also apply to related scripts. So let's start by refactoring the name from PlayerGroundComponentData to PlayerDetectionComponentData. Then add new field, EndFlag CollisionFilter. Next, let's refactor the name for PlayerGroundAuthoring and PlayerGroundBaker to PlayerDetectionAuthoring and PlayerDetectionBaker respectively. Let's add EndFlag belongs to and EndFlag collide with serialized fields. We need them to pass collision filter settings all the way to PlayerDetectionSystem. Also create getter with collision filter return type, of course with EndFlag parameters. Don't forget to pass EndFlag collision filter in the Baker. Now go to the PlayerGroundAspect and refactor the name to PlayerDetectionAspect. Also remember to change PlayerGroundComponentData name. Then add new getter, EndFlag CollisionFilter. Finally, let's rename PlayerGroundSystem and PlayerGroundJob to PlayerDetectionSystem and PlayerDetectionJob respectively. So from the beginning, let's create a private collision filter EndFlag CollisionFilter field. In onStartRunning method, let's assign this field to PlayerDetectionAspect EndFlag CollisionFilter. Then we can create checkbox method. It is faster approach than overlap box, and we don't need hits in case of ground and dead conditions. Fix cause and remove debug code. Also remove hits.dispose from isDead and isGrounded condition checks. Then let's move the hits code down. Let's add two fields to job, public collision filter, EndFlag collision filter, and entity command buffer ECB. Don't forget to pass ECB and collision filter to job. Let's copy getEntityCommandBuffer method from PlayerMovementSystem and paste it in the PlayerDetectionSystem. Of course, add missing require for update and pass parameters to job. I want to save invocations of the job when there is no need, so let's get singleton player component data and check if player is dead. If so, return. Also check if NextLevelComponentData exists. If so, also return. This will be helpful as we add NextLevelComponentData, so we can return early if this component exists. Again, add missing require for update. Let's go back to job implementation. Let's write bool is EndFlag equals overlap box, player transform box geometry, ref hits, EndFlag collision filter. In this case, I want to get hits because I can add NextLevelComponentData to the hits at 0 index entity. Why do this? It will allow me to check via LevelSystem, which I will create later in this video, if any NextLevelComponentData exists, and if so, invoke the NextLevel event. So if is EndFlag ECB.addComponent hits at 0 index dot entity new NextLevelComponentData, and at the end add hits.dispose. So it is time to create the NextLevelComponentData struct. Before we move on, I warmly invite you to support us on Patreon. Any support is really appreciated and important. On Patreon, I share materials in advance and add various useful code snippets. So back to the code, create a new file NextLevelComponentData that implements iComponentData. Add public bool is invoke. Setting this flag allows us to invoke the event only once. Then let's create LevelSystem class, which will be system-based. We'll use ManageAction class to communicate with UI. Implement missing functions. Add update in group type of simulation system group attribute and new public event action NextLevel. Prepare onCreate method in which we add require for update NextLevelComponentData, so system will not update if NextLevelComponentData doesn't exist. Inside onUpdate method, let's write var NextLevelEntity equals system API dot get singleton entity NextLevelComponentData. Also get singleton NextLevelComponentData because we need to change the isInvoke flag to true. If NextLevelComponentData is invoked, return. Let's invoke the NextLevel event and then set NextLevelComponentData is invoked to true. Set NextLevelComponentData via Entity Manager. Pass entity and modified component data. Last time we created GameOverController, but I want to improve the naming, so let's rename this class to GameOverWindowController. From now on, we'll mark all classes that relate to the UI and are windows with the word window in the classes. This will improve the readability of the code. Also, let's add UI directory to group UI classes. Now it's time to create NextLevelWindowController so we can handle UI logic. Let's create a new file in the UI folder, NextLevelWindowController, which inherits from monoBehavior. Create serialized field, GameObjectContainer. Also add header, references, attribute. Next, create private LevelSystem field. Then in the awake method, let's assign LevelSystem to word.defaultGameObjectInjectionWord .getExistingSystemManageLevelSystem. Let's also disable the container at startup. In the onEnable method, let's add a listener for the NextLevel event. In the onDisable, remove listener from event. Finally, let's create a new method on NextLevelEvent, in which we will activate the container. That's it for the code. Let's go back to Unity. Wait for recompile process to finish. Let's refactor PlayerGround to PlayerDetection and set up EndFlag CollisionFilter belongs to and collides with. Also attach NextLevelWindowController script to NextLevelWindow. Remember to remove GameOverWindowController script from newly created object. Press play and test if everything works. UI has opened, so yeah. One last thing, let's add an input log while the window is open. So let's move to input system and create new field, private LevelSystem. In the onStartRunning method, assign LevelSystem to entity manager.word.getExistingSystemManage LevelSystem and subscribe to the NextLevel event. In the onStartRunning method, let's remove listener to the event. Finally, let's create an onNextLevelEvent method that simply disables input controls. Let's go back to Unity, recompile, clear console, and press play. Now use input, and we are not moving. Great! In the next video, we'll focus on the subscenes and scenes management. Nice to have you with us, thank you for your engagement, until next time.